Hello guys, and welcome to this video tutorial of Maxsurf stability. So today I'll be showing you how to carry out a specified condition analysis and how to import load cases, create tanks and compartments. So before we get started, I'll quickly open Maxsurf Modeler first to show you a few things. So the first thing I've done on my modeler before importing the model is set up my frame of reference. So when you go on data, frame of reference, I've set my 0 point at the baseline, which is the bottom of my hole, the tangent, and I've set my aft perpendicular and forward perpendicular to the extent. So my 0 point is there. So you make sure that you set up your frame of reference before you import your model to Maxsurf stability. It will make your life much easier when you have to import a location for every load. Another thing I've done, I've taken some notes. So if you go on data and you go on calculate areas, here you can see your geometrical center of gravity given in longitudinal, transverse and vertical. So I've taken a note of those values. I've also taken a note on my design values. So if you go and calculate hydrostatics, here I've got my design displacement for my design draft at 0 trim. Here I'm also given my longitudinal center of buoyancy, my longitudinal center of flotation. Just a quick catch up, in case you don't remember, your longitudinal center of flotation will be the center, geometrical center of the water plane area, whereas the longitudinal center of buoyancy will be the center of the immersed volume, your center of buoyancy. So your LCF will always be behind your LCB. Okay, so having said all of that, after taking a note of my displacement and draft, I'm going to open Maxsurf stability and I will import my design. So I'll go on open design on the file. I'll select my model, open it. So then this window comes up. First of all, your surface precision, so that means how accurate you want your surface to be. So for the calculations that we're going to perform, I'll leave it on medium. If you want higher accuracy, go on highest. So I'm going to calculate no sections. I'm going to ignore my skin thickness, and here you can select the number of stations. So I'm going to keep it low, but again, the higher you go, the more accurate your calculations will be. However, it will take more computational effort, so I'll keep it quite low, 50 sections. Now if I click on OK, now Maxsurf will calculate my sections. They are not displaying yet because they're turned off by default. So if you click on sections, now you can see all of your sections. So this will be the sections that Maxsurf uses to calculate all the volumes and to perform all the calculations. Then here I can turn on my water plane. So now you can see your design water line where it goes through. Now you can select your water lines. We won't be able to see them from this view, but in this case we don't need them, so I'm happy with this so far. Here you can see your sections a bit better. Okay. So probably the best point to start will be setting up a analysis. So if we go under the analysis tab, right now we can only carry out specified conditions. So if we go on specified conditions, which is the one set by default here. So under this tab you can see all different types of analysis: upright hydrostatics, large angle stability, equilibrium, specified condition, kn value. So we're going to start with specified condition, which is the simplest. Now when you go on analysis, first you have to set up the conditions before you run the analysis. So click there, and we have several options. So you can, for instance, enter a displacement, and Maxsurf will calculate your draft for that displacement, or you can do it the other way around. You can enter a draft. So in our case, our design draft was 0.48, and Maxsurf will calculate a displacement for this draft. Then you can also enter a hill, so in angles, or you can make a free to hill. I'll show you that in a minute. Same goes for the trim. You can select a fixed trim, so in this case it's 0, or you can keep it on free to trim, which I will explain you shortly. You can either enter a trim angle here, so either a value in meters, so positive for trimmed stern and negative for trimmed bow, or you can enter your draft in 2 units. So you can enter your draft forward and your draft aft, and that will calculate your trim. So I'm going to keep my draft Emmet shapes. Okay, so I will now explain you these 2 options, free to hill and free to trim. That means that if you enter your center of gravity in this window, it will calculate your trim and your hill for that particular center of gravity. So if you don't want to be specific entering a center of gravity, just leave your trim and your hill fixed. If you want it to be accurate, then you already have an idea of your center of gravity, then enter your center of gravity, your longitudinal, transverse and vertical locations, and leave it on free to trim and free to hill, and it will calculate it accordingly. So in my case, I'm going to enter the center of gravity that I obtained from Maxsurf Modeler. So it was 5.46, my transverse was 0, and my vertical was 0.64. Okay. So now, if I click on OK, after I've specified the conditions, if I now click on display button, start analysis, or I believe that it is here at the bottom as well, start specified condition analysis, any of them too. If I click on it, it will run the analysis. There we go. So it has calculated my center of buoyancy for this condition, my center of gravity of the solid. However, because my trim and my hill were fixed, it didn't update. So it just calculated my hydrostatics for those values. So if I now go on my results window, which is here, current results window, this window will come up, and now I can see all of my hydrostatics for the specified conditions. So I can see my draft, my displacement, and so because I entered my my design displacement, I obviously got my design draft from Maxsurf modeler, so you can obviously see that it matches perfectly. So if I now go back to my analysis and change my specified conditions, if I now say, I'll change my view first so you can see it. When I say free to hill, free to trim, I click on OK and I reload it. As you can see, it trimmed because the center of gravity and the center of buoyancy aligned. So if I modify these conditions and maybe change my longitudinal center of gravity and move it 6 meters ahead, click on OK. As you can see, it changed again. So if I make it maybe 4, yeah. So that's how you actually use your specified condition analysis. You fix a hill and a trim and give it a displacement, or you give it a center of gravity and leave it free to hill or free to trim, and it will calculate it for you. So okay, let's move on to the next one. So we'll probably go on equilibrium, and the next thing we'll do, we'll create our own load case. So if we go here on load case window, I've just opened my load case window, as you can see here. Because I have empty load case 1, 2, 3, 4, 5, 6, 7. I have 7 of them at the moment. Okay, so in this window I can select the load case that I want. And right now by default I'm on intact stability. So the first thing I will do, I'll hold Control and press A in order to create a new load case, and I will call it, I'll just leave the default name, load case 1. You can, for example, create a load case only for your lightweight, a load case only for your dead weight, and as many as you want. Okay, so first my light ship, my mass, which is my displacement, is 5.6 tons, and my center of gravity is 5.46 longitudinally. Transversely is 0, otherwise it would be heeling to port or starboard, and my vertical arm is 0.64. Okay. So now if I click on Control A again, now I can place another item. If I double click, I can change the name. So I'll make this window smaller so I can see my profile view. Okay. So let's make these. Let's give this item any name. For instance, a battery. Now if I go on unit mass, you can also select the quantity, so I've chosen 1. So the mass is right now in tons. So in order to make it a bit more exaggerated, I'll make my battery half of a ton, just so we can see a difference that we can appreciate. And now we have to give it a location. So if I place it somewhere just behind the center of gravity. So maybe 4.6. So double click here, type in 4.6. Then my transfer is going to be 0 and my vertical is going to be maybe 0.5. Okay. So now when I press play, you will see the sinkage and the trim have an effect in this new load case. Yeah, as you can see, we have a bit of trim and we have a bit of sinkage, because if we now go on our results window, which is here, you can see how the draft was. Before it was 0.48, now it's 0.49. The displacement has also changed. Our heel is still on 0 degrees. As you can see, our draft aft is now 0.557. So here you can see your trim. Now your trim is positive by the stern. Your waterline length has also changed. Now it's greater because of the sinkage. Now your beam is also greater. Your wetted area, your waterplane area. And here you can see your other values like your prismatic coefficient, your block coefficient, your maximum sectional area coefficient, waterplane area coefficient, LCB, LCF, your distance from the keel to the center of buoyancy, distance from the keel to the center of gravity, distance of buoyancy to metacentric height, transverse, longitudinal, your transverse GM, your longitudinal GM. Basically all your hydrostatics are here. So this tool is very useful when it comes to place your weights and visualize how they affect your sinkage and your trim. So yeah, it is quite a powerful tool. You can also, for example, visualize your graphs. So if I open my graphs window, now I can view my curve of areas. However, this is telling me only about my immersed curve of areas on these specific analysis. So if I, for example, reverse what I did, if I change these to 0 and recalculate it, it should change. Yes, so you can see now I've got my original curve of areas here. So I calculate your curve of areas for this specific load condition. So yeah, it's quite useful to visualize how you, when you shift weights around, how they will affect your stability. You can, for example, if I bring my battery back, I'm going to make it 1 ton just so you can see the effect of it. If I now move it 1 meter transversely and I load the analysis, as you can see now it's healing. So when I see my hydrostatics, you can see the degrees here, so 6.1, quite handy. I'll show you something else that you can also do, which is you can, for example, set waves. So if I go here on my wave profile and I go on sinusoidal, I'll leave the default, which is the whole wavelength. So you can see that the wavelength matches the waterline of the hole. Now it generates the wave. So if I now hit play, it will calculate the interaction with the wave. If I now go on display and click on animate, it will just animate this motion. So it can be very helpful when it comes to analyze to pre-visualize your pitch in motion for your hole, or you can, for example, view it in perspective. If I make it rendered, just rendered this view. So now I can again animate it, and you can see the interactions. Okay, so let's move on. So the next part, actually before, I will show you how to display your masses. So here you can click on this icon, Loadcase masses, and it should display them. So the next point will be tanks. So I'm going to go on this window here, room definition window. I'm going to click on hold Control and press A, Control A. So here you select your type, whether you want a tank or a compartment. Here you type in your permeability, your damage permeability. So that means your interpermeability will be how much volume can you fit in the tank, and your damaged permeability will be how much volume can ingress your tank in case of flooding. So here you type in your aft, the aft location of the tank. Before you can select your fluid type. So if I, for example, want a ballast tank, I will write water, press enter, and then it will calculate my water ballast. And as you can see, the specific gravity density is 1.025. All of those values will be under analysis density. So these are all the library that Maxsurf uses for inputting tanks. So if you type in fresh water, it will give you that density 1. If you type in diesel, it will be 0.84, and you can always edit them to see the values accordingly. Okay, so my aft position, let's say that I want to make a tank that roughly starts around here. I make my aft position 2. Now if I want my tank to be 1 meter long, that means I'm giving it the location from my reference point. So if I want it to be 1 meter long, then I would have to type in 3. Now if I change my view, now I have to give it a port and starboard location. So if my 0 is here, let's say if I want my tank to take all the breath of my boat, then let's say I'll give it -2. It doesn't matter if you exceed your breath when you enter the details, and you will see why. So -2, and then I want it to end in my starboard side by 2 meters. Now I want my top to be maybe 0.5 of a meter, and my bottom I want it to be 0. And this is very important. We want it to be prismatic, and you will see what that means in a second. So if I now click on this button, update loads, it will generate my tank. However, we can't see it yet because it's not selected. So if I now click on intact tanks, there we go, it has loaded my tank there. I can also select the center of gravity of the tank, and it will select it. If I change my view now, I'll turn off my sections. Because my tank is also displaying the level. This is the button to display your level, so it shows that line. Then this option allows you to display the center of gravity for that tank, and as you can see, because it's prismatic, even though we're exceeding the dimension, it just adapted our dimensions to the whole form. I'll also change my wave type again and bring it back to flat. Okay, so by default it's at 50%. So now if I open my load case window, as you can see, my tank is at 50%. So I will change that and make it 100. There we go. So now my tank is 100. So here it will calculate my volume. So my volume is if I run this 0.5 of a cubic meter, and my mass is almost 500 kilograms, so almost half a ton. It's also telling me here the center of gravity of the tank in accurate numbers, longitudinally, transversely, and vertically. So let's say that you wanted your tank to have a volume of, for instance, 0.3 cubic meters. Then you will probably struggle. You will probably go back to your room definition window, and you would play with the dimensions until you get something that matches your volume. However, there is an easier way of doing this. So if I go back to my load case window, if I want my total volume to be 0.3, so I'll type it here, 0.3, press enter. And now because my new volume is 0.3, here it tells me that in order to be 0.3, it would be 62.82% of its capacity. So now I can copy this figure. I can go back to my room definition window, and I can change my intact permeability to that figure, and then press enter, and that will adapt to my tank. So now as you can see, it's 99.99% full, and the volume has already changed, so it's all accordingly. So that's how you create tanks. So you can create as many items as you want and place them around your hull. Same with the tanks, you can create as many as you want, place them, check your equilibrium condition. That will allow you to foresee how these changes will affect your sinkage, trim, and hydrostatics, and also the effect on the center of gravity. You will always calculate your overall location for the center of gravity for the total load case. You can also visualize everything in 3D as well. So here you can see your tank. It's quite small outside of my water line, so you can see it. So that's a location of my tank in 3D. So something else we can do is adding compartments. For example, if I go back to my room definition window, and now click here, Control A, and I'll call this aft, Control A, mid, Control A, forward. And now where it says type, I will swap to compartment, and compartment. So my aft will start at 0 and go up to maybe 4. And it will go from -2 up to 2. I'll actually check my breadth first just to make sure that it matches. So my maximum will be, yeah, I'll make it 2.1 just in case. And I'll copy these two values and paste them on the other two cells. Okay, for my mid component, my aft will be the 4 of the previous one, so it will be 4. It will start where the other one ends, and my 4 will be 7. My forward compartment will start on 7 and finish on 11.4. I also need to give them a top and bottom dimension, so my top will be 2.5 for all of them. There we go. So it has now generated the 3 compartments. They are set to be prismatic. So as soon as I press update, now as you can see, they fit perfectly. So now it's showing all of my compartments. So it can be quite useful, for example, when you want to analyze your damage stability. We will see that in another tutorial. So that's it. Thank you for watching, guys, and I'll see you in the next one. We will be discussing upright hydrostatics, large angle stability, KN values, and floatable length.